Hello, and welcome to Physics for Play. This is the first in hopefully a series of videos that will explore how do you take physics theories, play with them, test them, make hypotheses with them, and how do you test those hypotheses using computer simulations. So why are we putting together videos that explore this? Well, if you pop onto YouTube, there's no shortage of really great physics content out there, from SciShow to Crash Course, many more than I can fit on this slide. And all of it is really good stuff, and you should definitely check out because it's great for getting inspired about the amazing discoveries that people have made. Whether that's relativity or quantum mechanics, there's a lot of really interesting, counterintuitive physics facts that are just exciting to learn about. But if you're a geek like me, one of the things that you're left wanting of if you explore some of the YouTube channels out there is being able to play with the physics theories. So, typically what happens with me is I'll go to a YouTube channel, watch a physics video, get inspired by it, and then that's pretty much it. You get to hear about facts or hypotheses that people have made, but you don't really get a chance to play or make your own hypotheses, or especially even go and build out a theory and test how that theory might work. So the goal with this series of videos is really to explore how you can start to do that in a very basic way. And to do that, I'm trying to take these 4 principles that'll hopefully allow you to go beyond what you might have learned in a traditional physics class, or what you might get just from watching some of the great YouTube content that's already out there. Like I said, we want to go beyond what you would learn in a basic physics class. So this is not just going to be a tutorial where you learn how to solve problems and you go and you learn the basic content that you're gonna see in an introductory course. There's a lot of other really good material out there. There's videos. There's MIT OpenCourseWare. So we didn't want to replicate that. There's already a lot of really good stuff out there. So we wanted to make it beyond what you'd get in a physics class, but also still simple enough that you can play around and have fun and make changes and really learn physics by doing it. We also wanted to put something out there that was affordable. So as much as possible, we're going to do things where, the most you're going to need to do is have an internet connection and run some computer code, and then you don't have to worry about buying expensive equipment or anything like that. And then the last thing I wanted to make sure we included was some form of computation. If you talk to people who started off as scientists and engineers in college, but then got to a point where they thought, yeah, this isn't really for me, it's almost always because there was, a lot of times folks will say, well, I love the science. I just, I couldn't wrap my head around the math. So I ended up switching to another major. So we want to promote the math and teach how to do the math in such a way that hopefully it's not too scary, and give you some tools to play around and learn to solve problems on your own. So that's it for this introductory video. Check in next time, where we'll be kicking things off with looking at some simple harmonic oscillators and trying to solve those using computational simulations. Thanks for checking in, and goodbye for now.